Lesson 5-5, completing the square. Okay, so in this example, we want to solve by using the square root property. And one thing to notice is that the trinomial x squared plus 10x plus 25 is a perfect square trinomial. What that means is when you factor it, it factors into two identical factors. So x squared is x times x. And if you think about two numbers here that multiply to 25 and add up to 10, it's 5 and 5. Okay, so this is what I mean by a perfect square trinomial. The two factors are identical. X plus 5 times x plus 5 will give you x squared plus 10x plus 25. So if I factor the left side of this equation into x plus 5 squared, and we know it equals 49, I can take the square root of each side. Taking the square root of the left side basically undoes or cancels out the power of 2, and I just get x plus 5. And what I do to one side of the equation, I have to do to the other. So I'll take the square root of 49, and we know that that's plus or minus 7. Now 7 times 7 is 49, but negative 7 times negative 7 is also 49. So we've got positive and negative 7 as our square roots. And then finally, when I subtract 5 on each side, we'll get our two solutions. The first solution comes from positive 7 minus 5, and x equals 2. And the other solution comes from the negative 7 minus 5, and that gives us negative 12. So again, if I go back and relate all of this to the graph here, we can solve this quadratic equation by completing the square using the square root property. And the solutions 2 and negative 12 tell us that the x-intercepts of the graph are 2 and negative 12. Sorry, I drew my graph kind of wrong here. 2 and negative 12. Those are the x-intercepts of the graph. Okay, so the square root property can only be used, really this only works when the trinomial is a perfect square. So sometimes we do need to complete this square. Here are your steps. You're going to subtract c, basically move that number, that constant, to the other side of the equation. Then you take half of b and square it. Half of b and square it. Whatever that number is, you're going to add it to each side of the equation, and then you'll have a perfect square trinomial on the left that you can factor and then continue like we did the first example. So here's how it works. So x squared plus 12x plus c. We want to make this trinomial a perfect square, so what's the value of c that makes it a perfect square trinomial? Well, you take half of b. B is always the coefficient of x, so half of b, half of 12 is 6. And then we square it. 6 squared is 36. So c must be 36. Our trinomial x squared plus 12x plus 36 is a perfect square trinomial. The two factors would be x plus 6 times x plus 6. Okay, now let's put that into action and solve this equation. So x squared plus 8x minus 20 equals 0. First thing you want to do is check to see if this is a perfect square trinomial. Well, 8x in the middle, half of it's 4, and 4 squared is 16. I don't have 16 here, so I'm going to start by moving 20 to the other side of the equation. Now when I rewrite it, I'm going to leave myself a space here. X squared plus 8x. I'm going to fill in a value here that completes the square, so leave yourself a space. And now on the right side of the equation, I have 20. Now, what completes the square? Kind of off to the side here, you're going to figure that out. Half of 8 is 4, and then 4 squared gives you 16. So 16 is the magic number here that completes the square. I'm going to add 16 to both sides of the equation. One common mistake is that students will add it on the left to complete this trinomial, but they forget to add it on the right side of the equation. We want to keep the equation balanced, so make sure that you add 16 on both sides. Okay, the whole point of doing this is to factor it. It factors into x plus 4 times x plus 4. Well, why does this work? Well, 4 times 4 is 16, and 4 plus 4 is 8. And I want the two factors to be identical because I want to be able to write it as x plus 4 squared. Now, on the other side of the equation, 20 plus 16 is 36. Once you get to this step, you're ready to take the square root of both sides. The square root of something squared basically just cancels out the power, and we're left with x plus 4. And the square root of 36 we know is plus or minus 6. Now I'm going to subtract 4 on each side to get x by itself. And we do have two solutions here. The first one comes from positive 6 minus 4, so x equals 2. And the other one comes from the negative 6 minus 4, so x equals negative 10. These are the two solutions to this equation. And again, if you were to graph this, you could also figure that out. We also could have solved this by factoring, but we're using a new method, and that's completing the square. Okay, this is kind of a new one here. Completing the square, it doesn't always work, especially if you've got a number in front of x squared. If your leading coefficient of that a value isn't 1, then these are kind of difficult. So I can't really have a 2 in front of my x squared here, because if you think about it, I want two equal factors, and 2x squared doesn't split evenly. It would split into 2x times 1x. Well, those are not the factors that I want to have. So the first thing I'm going to do is divide everything by 2 to cancel out the 2 in front of the x squared. And as long as I do this to every single term, the equation will stay balanced. Okay, so now I've got x squared minus 5 over 2x plus 3 over 2 equals 0. 0 over 2 is 0. Now, 3 over 2 is not a perfect square, so I'm going to move it to the other side by subtracting it. And now I have x squared minus 5 over 2x. I'm going to leave a space for when I complete the square, and 0 minus 3 over 2 is negative 3 over 2. Now, I like working with fractions, so I'm going to continue to work with fractions here. Now I'm at the point where I want to figure out what should I add in here for c, my constant, so that I've got a perfect square trinomial on the left. Well, I'm going to take half of b, so kind of off to the side again, half of negative 5 over 2. If I multiply it by a half, I'm going to get negative 5 over 4. Then I want to square that number. Negative 5 over 4 squared gives me 25 over 16. So I want to add 25 over 16 on both sides. Okay, so now I'm ready to factor. Well, how does this factor? It must be x times x, and it must be negative here since my b is negative. Two negatives will multiply to give me a positive. I probably need in here 5 over 4, because negative 5 over 4 times negative 5 over 4 gives me positive 25 over 16, and when you add them up, you'll get negative 5 halves. On the other side here, I need a common denominator to add these, so let me just kind of do that work to the side here. My common denominator is 16, and I need to multiply this fraction by 8, so I've got negative 24 over 16 plus 25 over 16, and I get 1/16. Okay. At this point, I want to rewrite it so that my factor is squared. X minus 5/4 squared equals 1/16, and I can take the square root of each side. I'm going to switch colors again, otherwise it gets sloppy. Okay, so we're going to take the square root of each side. Again, this cancels out the power of 2, so that's really why we're doing it. And I get x minus 5/4. Now the square root of 1/16, well, the square root of 1 is 1. The square root of 16 is 4, so I get plus or minus 1/4. The square root of 1 over 16 is plus or minus 1/4. Now finally, I want to get x by itself, so I'm going to do the opposite operation here and add 5 over 4 on each side. By the way, if you wanted to do all of this with decimals, you definitely could have. I just prefer working with fractions. Okay, so what are my two solutions? If I take positive 1/4 and add it to 5/4, you keep the common denominator, so I'll get 6/4. And 6/4 is 3/2. My other solution comes from negative 1/4 plus 5/4. Well, that'll give me 4/4, or 1. So my two solutions here are 3/2, or 1.5, and 1. Okay? So again, is this the only method we can use to solve? Well, no. We know that we can graph, we know that we can sometimes use factoring, and we know that we can use completing the square now. Just another option or another kind of tool to use to solve these quadratic equations. Okay, last one. I want you to try this one on your own. X squared plus 4x plus 11 equals 0. And bring your answers with you tomorrow in class.